This is a quick video to explain the difference between a carbon sink and a carbon source. A carbon sink is anything that takes gaseous carbon like CO2 or like methane out of the atmosphere. So carbon as a gas turning into usually a solid. That solid, that carbon as a gas turning into a solid, that might be lots of different things. That might be wood, it might be sugar, it might be limestone. It might be lots of different types of things. It might be fossils. It might be dissolved CO2 into water. But out of the atmosphere is the important part for sinks. So the ocean is a great carbon sink. Lots of CO2 dissolves into the ocean, and there's also lots of plant life in the ocean that uses CO2 for photosynthesis. Trees are a good carbon sink. They do photosynthesis. They take CO2 out of the atmosphere to make carbohydrates like cellulose or glucose. Rocks like limestone have lots of carbon in them. Not all rocks have carbon, but some do. Fossils, and this is not just fossilized things like skeletons, but fossilized means preserved or otherwise buried deep underground in such a way that that carbon is not coming back up soon. So processes that take carbon out of the atmosphere, carbon sinking processes, might be things like dissolving, the CO2 in the air dissolving into the ocean. Sedimentation, bits of plant life or animal life sinking down to the bottom. Decomposition, where we have carbon contained in a living thing or a dead thing being broken down into the carbon in the soil. Fossilization and photosynthesis, I think we've talked about before. For carbon sources, they just do the opposite. They take carbon that is stored in some way and put it into the atmosphere. So a carbon source takes some kind of carbohydrate, whether it's oil or coal or wood or sugar or limestone, and creates something that's a carbon gas like CO2 or methane. They're two really popular ones. So sources could be the same things as the sinks. This list is the exact same as this list. That's not a coincidence. This is like a bank where you put your money into or out of. You either have deposits or withdrawals. So you can take carbon out of the ocean, out of trees, out of rocks, out of fossils, usually by heating them up, digging them up, or burning them. So some processes that add carbon to the atmosphere are respiration. We do respiration, plants do respiration. That's where we take oxygen and usually glucose and turn it into CO2 and water. That CO2 in the atmosphere is now in the atmosphere, so it's a source. Combustion just means burning, taking something flammable like wood, oil, coal, burning it. Deforestation is a carbon source because when we cut down trees, we also, parts of them rot, parts of them are burned, parts of them are otherwise recycled back into the atmosphere. Some of them get turned into things like buildings, but a lot of the deforestation in the world is not for lumber, but rather for clearing land for farming. Cement is a surprising one. Curing cement, when cement hardens, it takes a long time to fully harden, and all the time that it's fully hardening, it releases CO2 into the air. We build lots of things out of CO2, humans do. So this is a significant source of carbon dioxide being introduced to our atmosphere that was previously in limestone, previously in a carbon sink. Decomposition shows up on both of these lists. Decomposition can put carbon into the soil, but it also is done by living things, and those living things do cellular respiration, which means that they are taking some of that CO2 or that carbon in living or dead material and putting it back into the atmosphere as CO2. Now, if we look at the CO2 concentration in the atmosphere, this is their border here was 1750 for this particular graph. Pre-industrial age, the CO2 level in our atmosphere was around 250, 270 parts per million. In the intervening years until now, we know that human activity And this is just in counting human activity, not counting things like volcanism or other animal respiration and stuff. We know that we have increased that level by a bunch, but that some of it has been put into carbon sinks, like dissolved into the ocean or taken into new plants and trees. Overall, though, we've got this discrepancy, this growth in the amount of CO2 in our atmosphere of around, and this is an estimate here, but around something like 100 parts per million. That is a very big increase in CO2. That is something that is noticeable, something that is worrying. But if we didn't have these sinks functioning, that level would be way higher. It would be over 500, which would be an even bigger disaster than we're currently facing. Okay, so carbon sinks are anything that takes gaseous carbon and puts it into a solid or a liquid sometimes form, and a carbon source does the opposite, puts it back into the atmosphere.